Welcome back to my channel. Today I'm going to show you how to build a basic CRUD application using Spring Boot. CRUD is nothing but create, read, update and delete. And these are the core operations we perform in most backend applications. We'll use Java, Spring Boot, Spring Data JPA and in-memory H2 database to keep things simple and focused. Let's jump in. First, I'll explain you about Spring Boot and then we'll set up our project using Spring Initializer. After that, we'll create a book entity and set up our repository and build a REST controller. Finally, we'll run the app and test it using Postman and the H2 database console too. Alright, let's get started. Firstly, Spring Boot is the main framework that makes it easy to build web applications with Java. It's built on top of Spring's framework, but it removes a lot of boilerplate setup. It comes with the features like auto configuration, embedded servers like Tomcat, built-in support for REST APIs, and it's production ready out of the box. So it's perfect for building microservices and backend APIs fast and cleanly. Firstly, coming to the project setup, let's start by creating our project using Spring Initializer. So we can go to the start.spring.io and initialize our project. So I have selected the project type as Maven and the language Java and the Spring Boot version 3.5.3. Here we can mention the metadata of our project, the artifact as demo or some example or the project name. We can give the description, package name, and the packaging as a jar or var, and we can select the language, Java 21 or 17. Here we can add the dependencies. We can firstly, I'm going to select the Spring Web. It includes RESTful applications for MVC and it uses Apache Tomcat as the default embedded container. Next, I'm going to select Spring Data JPA, which will persist data in SQL stores like with Java persistence APIs using Spring Data and Hibernate. Next, I'm going to select the H2 database, so which provides fast in-memory database support for our JDBC APIs. Like with a small footprint, it supports the embedded server model as well as the browser-based console application too. So once we have added the required dependencies, we can click on generate the project and open it in your IDE. So here I'm using IntelliJ as my IDE, and you'll see the structure, the main application class, and the resources. So once you unzip the Spring Boot project and open it in your IDE, whether it's IntelliJ or Eclipse, you'll see a basic folder structure that looks like this. I have named my project as CRUD application. Here, all folders, we have the Maven, source, target, and everything. So the source folder is the important folder for us to consider now. Inside the source folder, we have main and test. Inside the main folder, we have Java. So this main source folder, it contains all the Java files, including main application class and the package for your controllers, models, and repositories. Inside the Java, controller is for our REST endpoints, and the repository is for our JPA interfaces, and the model is for our entity classes. Inside the resources, this folder contains configuration files and static resources. The most important one is the application.properties. Here, where we define the database configurations like H2 console access, server port, and JPA settings. Next comes our CRUD application. This is important root pack, which is the root in our package. This is our main entry point. It contains main method and is annotated with Spring Boot application, which tells Spring Boot to auto-configure everything and start the application. And one more important file in our application is pom.xml. It means like this is our Maven build file. It includes all the dependencies like Spring Boot Starter Web, Spring Data JPA, and H2 databases. So we have our Starter Web, the Data JPA, and the H2 databases. And the other important folder is the target folder. This, once you build your project, the Spring Boot compiles everything into the target folder. This is where the .jar file is created, which you can run independently. So now we understood the structure. Let's start with understanding the coding of our model class, repo, and the controller. Let's start with our model first. So inside the model folder, I have already created the book.java to explain it to you very clearly. So this book class, which acts as our database model, it is marked with @entity @table name as book. So Spring knows to create a table named book in the database. And the ID field is our primary key. It's auto-generated using generated value. We also have two regular fields, title and author. And to avoid writing boilerplate code manually, we use Lambda annotations like the getter, setter, and the no are constructors or all are constructors, which automatically create getters and setters and constructors for us. This class defines the structure of the data we'll store and manage with our CRUD operations. So next, let's go to our repo folder. Inside the repo package, we have the bug repo. So this is our repository interface, bugrepo.java. It extends JPA repository, which is a Spring Data JPA interface that provides built-in CRUD operations. Here we pass two types, the bug, which is our entity class, and the long, which is the type of our primary key. So thanks to this, because we don't need to write any SQL or even method implementations because we automatically get the methods like find all, save, find by ID, and delete by ID ready to use. Spring will handle everything under the hood. Now, let's look at our bug controller class. This is where we define all our endpoints to handle CRUD operations for the bug entity. The class is annotated with the REST controller, which makes it a REST API controller in Spring Boot. And we inject bug repo using AutoWire to interact with the database. Here we have the get mapping to get all the bugs. So this is the endpoint which returns all the books from the database. First, we fetch all the books using find all and then return them as a list with the status as 200. Okay. And if the list is empty, it returns the 204 with the no content. And if something goes wrong, it returns the status 500 with the internal server error. Next comes our get book by ID. Here, this is the endpoint which retrieves a single book by its ID. If the book is not found, it will return not found. And if the book is found, we'll return the status code as 200 OK. Otherwise, 404 and not found. And next comes the post book. Like we are adding a book to the database. This endpoint is used to add a new book. Like we take a book object in the request body and save it using bookrepo.save. Then return with the status 200 OK. And next comes our post mapping. Post update book by ID. Here we can update the existing book using its ID. We first check if the body exists. If it does, we update the title and author, save it back, and then retain and update the book. If not found, we'll return 404, not found. Next comes our delete book by ID. This endpoint deletes a book using its ID. We simply call delete by ID and return status 200 OK as a confirmation. So this controller handles all the CRUD operations, create, read, update, delete. Each method is tied with specific HTTP request type and uses Spring Boot built-in features to return proper HTTP status codes. Let's now run and test this API using Postman. So I'm just running my CRUD application. Let's see what happens. Here, my Spring Boot application has started with version 3.4.2. And it creates the table bug and it creates the sequence with starting with 1. This now starts the embedded Tomcat server on port 8080. You'll see the startup logs here in the console saying start that CRUD application. And now let's test it using Postman. Now, before starting testing our Spring Boot API, let me give you a quick intro to the Postman. This is Postman, which is a popular API testing tool that lets you send HTTP requests like get, post, put, delete directly to your backend without needing a front-end application. It really helps for testing your endpoints during the development. You can send the data in JSON format. You can add the body here and without any front end or anything, you can send the JSON format and view responses, check the status code, and debug the errors all in one place. Here we can get the output. Let's begin with the first endpoint, get all books. Here we are using get method and the URL will be localhost 8080. When we click on send, here it returns 204 no content because there are no books yet. We'll get the status code as 204 for the no content, and once we add the data, this will return a list of all the books with status code 200 and OK. Now let's add a new book to the system. I'm changing the request to post. Here my URL will be add book. And go to the body tab and select raw, and we can add our title and author here. Now, if we have the sample data, we'll just add it and then click on send. You'll get back the newly added, the created book with generated ID because we have set it as auto-generated with the status code 200 and OK because the request is successful. Now, let's test with get. We'll get book by ID. So here for get book by ID, we have our URL something like this. We'll take this URL, paste it here, and we'll add the ID. So if we mention get book by ID and mention 1, so we'll get the particular output of the particular book. If we want to add more books, so we'll just try to add more books and then test it. So we will add one more book. I have the sample data. I'm just adding it. I have one more sample data. I'm just adding it and click on send. So now we have 3 bugs in our database. Let's just test it. So we will get all the bugs data here, 1, 2, and 3. Now to get fetch particular book by ID, we have the URL get book by ID and mention ID beside it. So I'll just paste the URL and change the ID to 2. So here in the output, we will only see the book with ID 2. If we want to search for any other book, if I want to search a book with ID 4 and click on send, we won't get any response because if book exists, you'll get back with the status 200 and okay, but if not, you'll see 404 not found error. Now, if we want to update a book by ID, let's see what we want to update, the title or the author of the book. Here, we have the URL to update the book as update book by its ID. So I'm just using this URL here and I'll change the book to, I'll update the author name as James. So let me change the request to post and then send it. So now you can see the output. The ID, the book with ID 2 has changed the title Spring Boot in Action and the author to James. So you'll get back the updated book with status code 200 and OK. If the ID doesn't exist, the API will return 404 and not found. If we want to delete a book by its ID, we can mention delete and we need to change the URL. We can take the URL from here. So the URL will be something like this, delete book by ID. We want to mention the ID of the book which we want to delete. Here I'm giving the ID as 1 and send. Here we can see the status 200. Okay, the book will be removed. We cannot see any output because it's deleted. If we are trying to call a get method again, you'll get all the books except the book with ID 1. We can see the bugs with ID 2 and 3, but not 1 because we have deleted it. That's it. We have tested all the CRUD operations using Postman to create, read, update, and delete. And everything is working as expected. This proves our Spring Boot backend is ready and support the real-world front-end applications. So here, coming to our next slide, just a recap. We have built a fully functional Spring Boot CRUD API with a simple book model repository for our database operations and a controller to expose all the endpoints. We have connected to the database. The Spring Boot auto-configures the H2 in-memory database here, and the database settings are defined in application.properties. And we have built the RESTful APIs. We have used the read all for get, post, put, and delete. We have used Spring Data JPA and in-memory H2 database and tested everything using Postman, covering all the 4 core operations, create, read, update, and delete. And thank you so much for watching this video and understanding the coding along with me today. I hope this tutorial helped you to understand how to build a Spring Boot CRUD API step by step. If you found it useful, please consider giving a video like, sharing it with your friends, and subscribe for more developer-friendly content. Your support truly means a lot. See you in the next one, and until then, happy coding!